Again, we are at this question. So on today's lesson, we are going to look at this rotation motion question. Yes. So at this, the question reads: the figure below shows a solid sphere with a radius of 8 centimeters starting from rest and rolling down a frictionless plane 2 meters long. So the plane is 2 meters. So as usual, our height is supposed to be this one. So we are going to on this question we will use the principle of work, energy and power. That's the principle which can help us solve this question. So the formula on this question, so let us say solutions. So the formula for this one, we are going to say, and don't forget that this was frictionless, so there was no work done by what? By friction. So we are going to say mg h is equal to what? Half a squared plus what? The rotation motion of this object, because as the object was lowering down this plane, it was also doing what? Doing the rotation motion, not just the linear motion. This is the linear motion, but we should also consider for what? For rotation motion. So we are going to say half squared. This is what? The formula, how the kinetic rotational energy. This if you don't know how to drive this, you can comment in the comment section. I'll help you, but as we will be answering this, I'm sure you will know where it comes from. So, and we should also consider that so first let us focus on this part. Don't forget that this moment, this inertia, this moment of inertia is what this is what is a solid sphere. Different shapes have different what? Inertia. So we should know that for this one, inertia is denoted by what? Or is equal to what? So we can cut here. So inertia will be equal to what? 2 over 5 mass times what? The radius squared. So we should consider that. We should also know that different shapes, it depends. You can be given a solid disc. A solid disc has 1 over 2, but here let me not confuse you. So we have this. This is what? Inertia. So from this we can now replace. So we can replace this. Let us try to just concentrate on this part. So we are going to say that for inertia, so for this part where we have inertia, we are going to replace with what? With this. So we are going to have kinetic energy of rotation. It will be equal to half over, so half times 2 over 5 times m times r squared times, then on this one, this is what? The angular velocity. We know that angular velocity, velocity is equal to what? R times the angular velocity. So when we make this subject of the formula, we are going to know that R over R, this will be equal to what? V over R. So where we have this, we are going to replace with what? With this, so that we have, so we are replacing here, so we have times squared, yeah. So we now have what? I'm just continuing here. 1 times 2 is 2. 2 times 5 it's 10 m, just like that. Then this, when you do what? This, like when we're dividing, how we distribute the square root, it should be on both, on the denominator and on the numerator. So this r is squared, so this r and that r will cancel. We will just remain with something like that. So hence our kinetic our rotational kinetic energy will be equal to 2 over 10 mv squared. So this is what we are going to replace here, so that we have mg h is equal to half mv squared plus 2 over 10 mv squared. You know, the mass will cancel, then we remain with g h is equal to half v squared plus 2 over 10 v squared. This is just the same. So here, to simplify things, you can just say 2 divided by 10, it is that, plus half is just what, 0.5. So you can now say g is equal to what, 0.7 v squared over 0.7 over 0.7. This and that you cancel. V is equal to what, g over 0.7. we square both sides. This and that, this and this will cancel. Then we are going to, v will be equal to what, g h over 0.7 squared. So now our height, what will be our height? Our height is here. So here we are going to use the grade 10 principle. Yeah, I know you are much familiar with this. So we are going to say, if you want to find this, we have been given what, the hypotenuse, and this is the adjacent. So for us to find this we are going, so what do we have? We want to find the adjacent and the hypotenuse. Oh, so this is the opposite. This is the opposite, and this is the hypotenuse. So when we use the SOHCAHTOA principle, we find that the what's associated with that is sine. So we're going to say sine theta is equal to what, opposite over hypotenuse, which is 2. This when we cross the multiplication, we are going to have h is equal to what, 2 sine theta. So our h will be equal to what, 2 sine 30. Sine of 30 is 0.5. 0.5 times 2, that is 1. Our h is 1 meters. Yeah. So our v will be equal to 9.8 times 1 over 0.7 of that, what, square root to the power half is same as square root. So we are going to say 9.8 divided by 0.7 square root of that is what, our v is equal to what, 3.74 meters per second. Yeah, this is our linear speed. So for us now to find the angular velocity, yeah, because we have the question has said we should find what, the angular velocity and the linear speed. So like from here I have driven I think I driven something here where I said v, this is omega is equal to v over r, and our r here was given in what, in centimeters, which is supposed to be in meters. So here I converted it, so here we can put 1 meters, which I converted, and we'll just substitute here. We'll just say omega will be equal to v over r, which is equal to what, 3.74 over our r is 0.08. We are going to say 0.08, which is equal to what, 46.77, which we can round off to, this we can round it off to 46.8 radians per seconds. Okay, so the last part of the question is to find what, how long does it take to reach the bottom. So from the previous question we solved that v is equal to 3.74, and the displacement was what, 2 meters, the length of the incline, and it started from left, so the initial velocity there was 0, and we are going to use this formula, which is displacement is equal to what? Yeah, as usual, displacement is equal to half v plus the initial time. And now we can substitute what we have. Our displacement is 2, half our final velocity is 3.74 plus the initial 0 time, which is what this is what we have to find. We can just multiply 2 times 2, this is 4, is equal to, this is 0, so we can just multiply 0 1 times this, which is 3.14, times t, which is 3.40, then we can just divide 3.47 across. We cancel that, find that the time will be, our time is going to be 1.0, can just round off that, which will be 1.7 seconds. Yeah, thank you my lovely viewers for your time. If you have any question, you can comment in the, you can post in the comment section. Yeah, we can just try to check up on what we have answered. So we started from here, there, until we found this. Then this is our last part. Thank you.